All right. Hope everyone's doing all right today. Exciting that we're well on our way to day 4. So scrolling down a little bit, and we'll be looking at data summarization and data classes today. So let's jump right in. All right. So before we get too deep into summarization and what all that is, we want to do just a little recap. I know we've covered a lot of things, but important to try and remember what we did. So we talked a lot about subsetting our data yesterday. So we covered functions like select, which is going to help us to, just take a subset of columns or actually reorder them. So just narrowing down the columns that you have in your data set. Filter is going to help us remove rows that maybe don't match criteria that you want. So you're just like, I only want values that are greater than 100. You could keep them that way. You can arrange to reorder your rows. You can mutate to create new columns or modify them. And you can combine functions together, right? We learned about the pipe, which is going to allow us to chain actions together. So I want you to do this, and then this, and then this. Multiple steps in our data analysis workflow. And then, in case you just are using select and you know that there's a column that you don't want, instead of having to list out all the ones you do, you can use the exclamation point. And definitely check out the cheat sheet for the quick recap of what we covered yesterday. All right. So just going into this module, we'll be using the Colorado heat-related ER visits data set. So, I know we've been going kind of back and forth between a couple, but we're kind of revisiting this one for now. And we'll use it for different ways of summarizing the data. And just to remind us, this data set is going to contain info about the number and rate of visits for those heat-related illnesses, right? So if there's a heat wave, sometimes folks get sick or have to visit the ER. So we'll want to try to keep track of that. All right. So let's read this data set in to give us something to work with while we're going to go over some of these concepts. And so to remind ourselves, head is going to display the first couple of rows of an object. And so let me type this in to my code here. And then so I'm just going to open up a R Markdown book to kind of keep my code in one place. All right. So again, code's going to go inside that chunk. I can save the file for later if I want. But I'm going to make a file or an object rather called ER. And I'm going to read from this URL. You can, of course, download that data and read it in from file if you would like. All right. So does anyone know why I'm getting this error? We're starting off strong. Ava already making errors in the console. What's going on? It can't find this function. Exactly. Yeah, I have to load the library, right? So I already have it installed, but every time I open up R, I'm going to want to make sure I have the right packages. So let's try that again. Let's try running this whole thing. Much better. Thanks for saving me, everybody. All right. And if we were to do head of ER, that's what our data set kind of looks like. We've got these 6 columns here. It's been kind of cut off because we're just using the head function, but I can kind of get a preview of my data that way. All right, so I got my data in hand. So a little bit of review here, but remember that pull is going to convert a single data column into a vector. It's just going to kind of extract those numbers and let you do things like do math on those values. So if I do something like ER and pipe that into pull, and I tell it I want to pull this visits column here, what does that look like? Okay, first of all, I've got a lot of missing values. That might be a little bit worrisome, but and some zeros. But I've got definitely some observations where there were quite a few ER visits for a particular year and category. All right, so it's pulling it into a vector. And so now that we have a vector of numbers, what are we going to do with it? Well, the exciting thing is now we can start to do some statistical summarization, right? We want to make some insights from the data. So maybe we would want to take the mean or the average, right? So you could take the mean of that vector of numbers. You could do standard deviation. You could do median, quantile. You can do range. sum, max, min. There's tons of these summarization functions, and they all work very similarly. All right. So we can use the pipe to pipe vectors into summarizing functions. So let's see kind of how that works. So I've got ER and poll of visits. I've got those numbers here. And because that's already a vector, it's ready to go. I can pipe that into mean. I'm going to take the average number of visits for each county and each year. So what happens if I do this? I get an NA value. So that's not super exciting. But if I take a look at the values in the vector here, I can see that I've got a whole bunch of NA values, right? So I've got some here, all in here. And R is trying to be strategic here. It's saying, well, you've got missing values. I don't know what you want me to do with them, right? Maybe those missing values are so high that they're off the chart. Maybe they're all so low that we have that it's basically zero, right? Sometimes missing values are meaningful, and R doesn't want to make that assumption for you. However, if you're like, I just want to get rid of those NAs, those missing values, and just take an average of what's left, we can provide a argument to mean that goes like NA or missing.rm for remove. So missing remove equals true. So let's try that. All right. So if we take all those non-missing values and average them, we should get a little over 7 visits per county per year. And yeah, this argument is, again, going to get rid of those missing values from the calculation. All right. So we're looking at vectors into summarizing functions. So what kind of object do we need to run summary operators or actions like mean? Do we need a vector of numbers, a vector of characters, or do we need a data set? What do we need to take the mean? Yeah, I agree. A vector of numbers, right? A vector of characters, I think it would say, I can't do math on text, right? What is the name Ava divided by 3, right? It's like, it's not going to be able to figure that out. And a data set's got a bunch of different options, right? So like, if I asked it to take the mean of this data set, does it mean rate? Does it mean visits? Does it mean the mean year? It needs you to be a little bit more specific. So it's going to need you to take a column and turn it into a vector of numbers. Nice job. Okay, so that was a lot of work, right? We pulled that column out. We, turned it into a vector. Could we just do some summarization directly on those tibbles or data frames? Turns out we can. So let's talk a little bit about how we do that. All right, so we can do that with a dplyr function. So the dplyr package is inside of tidyverse, so we're still in familiar territory. We can do that with the summarize function, and it's going to work on data sets without having to use pull. And multiple summary statistics can be calculated at once, which is pretty neat. So this is more the general format, so hopefully not too much text here, but we're going to take the data set followed by the pipe. That should be a little bit familiar, data, then pipe, and then action. That action is to summarize. Here we create a new column name that represents whatever we're summarizing. So it could be like visits mean. And then here is where we provide, the function. So like mean or SD or median, and then the column that we want to look at. Okay, so how would we do this with what we were just doing? So instead of pulling out that column, what I can do is take the data set followed by the pipe and type out summarize. And so I've got to give it a new name. So on the left side is the new name, just like mutate actually. So we could do mean visits. And what is that actually going to be? It's going to be the mean of the visits column. All right, so let's try that. Okay, again, this pesky NA, right? It's not trying to make any assumptions about the missing data. So we also have to supply this NA.rm or NA remove equals true argument. So let's throw that in there. All right, great. So again, just over 7 visits on average per county and per year. All right. And so just like with mutate and some of our other exciting functions, we can do multiple at once. So we can take multiple summary statistics by separating with a comma. And so if we are saying, well, okay, I know the mean, but I also want to collect the median number of visits, can throw a comma in there and say median visits. This could, again, I could call it anything I want. It's the new column name that I'm creating. So let's do median of the visits column and na.rm equals true. All right. Median number of visits is 0. And so, that's our middle value. And if I scroll all the way up here to this vector that I can kind of see a little bit better the numbers, I see that 0 is super common, right? And so it makes sense that the middle value would also be a 0. That's not too unsurprising or too surprising. And again, if I wanted to add additional summary statistics, I could add another comma and just keep on going. Okay, so something important here to point out is that Summarize is going to create a separate tibble from the original data. So if you want to save a summary statistic in the original data, you could maybe even use the mutate column instead to create a new column for that summary statistic. So here, if let's say I save this as stats table as an object and then check it out, notice it's just a teeny tiny table, right? It's not actually doing anything to the original data. It's making something completely new, in this case, a summarizing table. So important if you're kind of doing lots of steps in reassigning. When you do a summarize, usually that's something else, and we don't want to reassign it to the original object. All right. Using a summary is also really handy. It can give us a rough snapshot of each numeric column. It's going to skip the character columns for us. It's just going to tell us that it's a character column and then give up and do nothing else. But summary is really fantastic because it gives us lots of information without having to remember too many pieces of syntax. So I was going to say, all right, well, I just want to do a summary on ER. It gives me lots of info. So it's saying, all right, here's the rate, here's the minimum, the median and mean, and the quartiles. It tells me how many missing values there are, which is kind of convenient. And if we go over here to visits, this 7.1 should look familiar for the mean and the median as well. Remember, we just calculated those up here. But, sometimes summary can be a little overwhelming. So if you remember, the CalEnviro screen data set has like over 60 columns. You'd have to kind of scroll through this information to find what you want. And sometimes that's a bit manual. And this way you can get the exact statistics that you want immediately and, be able to run the same code again if you need to. All right. So to summarize, we are using the pull function to create a vector. Okay. And that vector is what we can start to summarize. Right. So if we want to take the mean or the median or something like that, we might need pull first. And often that needs the na.rm or missing remove equals true added to it. The summary, not to be confused with summarize, the summary function is going to give us quantile information and lots of statistics. Summarize is going to create a summary table of the columns of interest directly from the tibble or from the data frame. And summary stats like mean and sum and SD, all of these are going to work with vectors that we created with pull, or they're going to work with summarize. So if you have kind of two scenarios you can choose from, you can pull that column and then use mean, or you can use mean within summarize. So it's just kind of your choice, which is the most efficient for what you're trying to do. Okay, so questions about summarization before we get a little practice with the lab. I would recommend that, yes. I think we saw a situation yesterday where we tried to pull multiple columns and it kind of strung them together in a very strange way. So yeah, generally I would say you should pull just one column at a time. All right, so the lab for today is right here. And also the link was in the chat, I believe. And I'm going to download it multiple times, apparently. Okay, all right. So I'll go ahead and just run this first bit of code to get us started. And if you can let me know, either just thumbs up or drop in the chat if you're able to get the file up and running and get this CES object set up. All right, we got a couple of folks are good. Maybe a couple folks need a minute. All right. Okay. So once again, we're trying to pay attention to what's kind of going on with our data set. So how many observations or rows are in the data set? I know we've done this a couple times at this point, but by now you should be experts, or maybe starting to feel that way, like you've seen this before. So how many observations or rows are in CES? Where can we find that information? Yeah, exactly. So yeah, I can check that out in the environment over here. We've been doing that a couple times, but important that we can find that other places too, right? So I got that many observations. I can see that in the console as well. And then if I wanted to, I could do row for number of rows and get that answer as well. All right. So the total pop column, it's including information about the population for each census tract as of 2010. And just remember, this is a small area. It's kind of like smaller than a zip code a little bit. And so what is the total population of the data set based on the 2010 census? So total population, meaning we want to add it up over every single row, the total population for all of them. And so if I take a look at the data here, I'll scroll over a bit. Right here. So total population, right? Telling us how many people live in that census tract. And I'm thinking, well, I want to add up the state of California. I want to get all of those values and figure out what the total population is. So I'll give us a moment to try that. All right. So, we're just looking at a column here, right? So we could try the poll approach where we just pull out that total pop column. So let's try that first. All right. So what is this going to look like for us? So this is a vector. You can kind of tell it's got all these indexes here on the left-hand side in brackets. But it's just trying to print all those numbers out for us at once. And so maybe I can just pipe this directly into sum. All right. So I don't think I have any missing values. So I, was able to calculate this without that na.rm equals true option here. And so let's see, does 39 million, a little bit over 39 million track with what we know about the population of California? I'm curious now. Okay. Maybe I'm not that far off, right? Google might be a little inaccurate, or perhaps this data set has some duplicates or something like that. All right. Questions about how the process that we followed to get the total sum of the population there. Yeah, I agree. So there are other ways to extract the total pop column. But I think, like using the tidyverse kind of approach with poll, I think that makes a lot of sense. I agree. Be careful about doing something like this. I think you had a really good example there that maybe we want to do something like this, but that's not going to work because poll is looking for a column name when we use it, but sum is looking for a vector. And so either we have to pipe the vector before, or we have to give the vector right here. So we could do something like, right. So you already pulled the column, you have a vector, so you don't need to specify the column again. Yeah. So sum is expecting a vector, right? It's not expecting you to tell it a column. So when we do this right before the pipe, that tells it, okay, put the vector inside of sum. But sum is not expecting you to give it a column name or an argument or an object called total pop. If we had done something like where we created a population vector, something like this. So I created the vector and then did sum of pop vect, that would work. Yeah. So, to give you an example, we're going to cover a lot of data cleaning steps tomorrow. And, we did like subsetting and filtering yesterday, but there's a scenario where you might take like your data and you might do a filter, you might do a select, then you might do like a drop NA, and then you might do a summarize. And so doing your code in this way, where you're taking all of those steps separated by that percent greater than percent or the pipe, is going to allow you to chain your steps of your analysis. Yeah. So it is a little bit more readable and interpretable way of kind of understanding the analysis you did. Yeah, nothing wrong with doing it in a different way without the pipes, but we think this is it's a little easier to get started, and B, it's a little bit more readable for other people. Good question. Yeah, it's like, why are we doing it this way? It's important to know why, right? And I just want to say that option works totally fine as well. The $ is the base R way of pulling out a vector. So CES total pop makes the same thing. So you could maybe even pipe that into some if you wanted to be really, really fun and mix up the tidyverse and base R. Yeah. So either way is fine. Generally, like sometimes I would say, not generally, but sometimes the $ notation does not always work great with the tidyverse function. So just might run into some issues if you end up doing that longer term. Yeah, good questions. Anything else about this one? Great. All right. So what was the largest population according to the 2010 census for a single tract? Basically, like what of the rows, what is the maximum population? So we're going to try to use summarize this time. I'll give us a moment to think about what that might look like. All right. So largest population for single census tract, use summarize and max. So in general, we're going to want to start with the data and take that into the pipe. And then after the pipe, just like we kind of saw up here, you take the data and then you start doing your actions. Like, what do you want to do to the data? And so that's where summarize will come in. Not sure why it's telling me there's something wrong with the code. It's upset about it. So when we do summarize, we want the summary column name or the new name, and then the summarizing function and the column over on the right-hand side. So what was the column that we wanted to look at? It was that total pop column, right? And we wanted to do the maximum. So maybe we would do pop max for the new column name, and we'll just take the maximum of the total pop, and let's see how that goes. All right. So 38,000 per one of the census tracts. That does seem like a lot. Fun fact, I can just go over to the CES table and I could sort the data this way. And that looks correct. Anyone get anything different? I feel like sometimes I might be a little off. Always good to check. I do want to show us kind of something a little funny about summarize. So turns out I can actually get away with not telling it what the new column is. So just giving it the summary function and then the column, but it makes that column name really ugly. So either one is an option. All right. And so let's modify that code to add the smallest population among census tracts. Use min in your summarize function. So we're going to start adding on more statistics. So let's take this one. We'll copy it down here. We'll add a little bit to it. I'll give us a moment to do that. All right. So let's add minimum here. We'll do pop min for our new column name. And we can do min of total pop. All right. So good to know. If we wanted to add some other things in, we certainly could do the median, could even switch those around, get rid of that comma there. And if we wanted to get kind of similar numbers, we could try summary. We'd have to kind of scroll around a little bit, but we get those same values here. All right. Any questions about summarize? All right. And just an exciting bit of preview for what we're going to do next week. So, let's say we made this little table right here, but I actually wanted to transpose it. I could actually pivot that table and have those values printed out in kind of long form. So lots of cool stuff we can do once we have the data that we want. So we talked a little bit about summarizing our numbers. And we know that not all of our data is numeric, right? So taking a look at our CES data that we were just playing around with, we've got a lot of numeric data, right? A lot of numbers, but we also have categories, right? Like the county, approximate location, different kind of city areas, whether it's close to a city or an unincorporated area. So we know we have categorical data too. And so we can use a function called distinct to tell us the unique elements of a specific column. And so this works pretty straightforward, very similar to select or to poll, is it's going to give us a output with a function and then the column that we specify. So let's kind of see how that works with the ER data set. We take ER and pipe that into distinct and county. All right. So it's giving us each distinct county name versus when we look at the data set kind of as is, we might see a repeated value a bunch of times. And so with this distinct here, we can see how many of those we have. We get a little clue here as to how many rows of that data there are, or we could just check out the dimensions up here that it is 64 distinct counties. So, just in the case that maybe you don't see that number of rows, right, with the distinct output, you can also pull the column and pipe that into a function called ndistinct. It's going to tell you the number of unique elements. If you happen to have a vector in some other instance, ndistinct will work with that as well. So we were working with the ER data and looking at the number of visits and counties. So we could pull county, and that's going to look like this. It's character data. I'm going to have quotation marks. And I've got a number of lines for each city or for each county here. But let's see how many distinct, and again, from the dplyr package, nothing goes inside the parentheses. It's just going to count up the number of distinct counties we have, 64 unique counties. There's also a really nice function called count, and it's going to return the row count per category. So if we were to take this on the same column, so ER, piping that into count, if I just leave count empty, it's just going to count the number of rows in the data set. So I know I have 768 observations. It'll give me the same information. But what if I want to divide it up by the unique counties? I could put the column name in question there. And it's telling me, oh, okay, I have 12 rows for each of these counties. And, what we said over here, we've got 12 rows or observations per county. And this is good, right? Like oftentimes we want our data sets to be balanced, right? We observed 12 years for each county. So maybe sometimes the data is a little more chaotic, but this data set's pretty well collected. Okay. And if I want to further subdivide the count, I can. So I could just add a column and then add a comma and then add another column that I'm interested in. So let's say, okay, I've divided it up by county, but I also want to see how many observations I have per year. And should hopefully not be too surprising, but I have only one observation per county and per year. I look at the data, just kind of taking a quick peek at it. Yeah, that does seem to make sense. Okay. And just because I have an entry, I have a line for each year and for each county, doesn't necessarily mean the data looks very good, right? So maybe Alamosa has a little bit, maybe more sparse data reporting for the emergency room visits. All right. So got check here. The count function that we were just looking at, it's going to help us tally the sample size, the rows per each category, or how many categories. I'll go back over here. All right, we got some B's. Anyone disagree? Yeah, I agree. I think it's B. So sometimes it might help you determine the sample size, but not necessarily. And then number of categories, we would probably use ndistinct for that. Yeah, exactly. All right. So let's talk a little bit about grouping now. Now that we've talked about the different kinds of categories we might encounter in text data or character data, grouping is going to be so useful for us. All right. So, the mean number of ER visits, but let's say we actually want to determine that for each year, right? So we had, I want to say 12 years in our data set. And, we want to take a mean across all the counties, but we want to break it down by year instead of just getting a total average in the data set. So how are we going to do this? The solution, I think, that's pretty nice here with the tidyverse is doing a grouping. So first, let's group our data, and then we'll talk more about what we can do. So we can use a function called group by, and then tell it what column we want to group by. So we're saying, all right, I'm going to create kind of like a version of this ER data set, and I'm going to take the ER data set and pipe that into the group by function, grouping it by year. Okay, so important thing to note. So I have ER and ER grouped. They have the same dimensions. The data sets are pretty similar, right? Nothing too different with those two. However, when I take a look at ER, all I see is, information about the dimensions here. But if I look at ER grouped, I now see this feature. It tells me, oh, it's got groupings. You've got a group by year. So nothing has changed in terms of the data itself, but this feature here is going to change how any functions after are behaving. Okay, so it's giving a big flag to your data set and saying, I want you to behave a certain way when you do follow up steps to your data processing or your data cleaning. And here you can see that again. Okay. So again, it doesn't change the data in any way, but it's going to change how functions operate on it. And so now that we've got this grouped data and we know that it's going to change the way that future functions operate on it, now we can start to do some more complicated summarizing. So I promise we didn't learn summarizing just to make our lives difficult, right? We can't do this with pull very easily. So let's try to summarize this data set. So let's take ER grouped, just like before. We'll pipe that into summarize, and we'll take the mean visits as our new column name. Shrink this down just a little. And that's going to be the mean of the visits column. Okay, remember it's already grouped by year. All right, I've got a lot of missing data still. So just like before, I have to provide that NA equals RM or NA.RM equals true argument. I'm going to space this out a little too, just to keep things clean looking. So let's get rid of those missing values. All right, so now I have each year, and then I have the average number of ER visits, and that is across all of the counties. And so maybe this would be something that I would do if I was thinking, all right, well, I kind of want to know if there were any years with particularly bad heat waves and if the ER visits were maybe a little bit higher in those years. I was actually living in Colorado for much of this time, and I don't remember it very well. So this could have very well been a very hot year. So, but I'd have to look back on what I was doing, probably inside doing lab work. So there we've got our summary by year and the average number of visits. All right. And we've been talking a lot about the pipe, and maybe we're wondering what the utility is. I think where it gets really powerful and really helpful is in stringing this all together. So I don't even need to make this intermediate data set. I could just say, all right, I'm going to start with ER and I'll pipe that into group by and then keep on going. I'm going to pipe that into the next step. Take the mean visits where it's the mean of the number of visits, and we're removing any missing values. All right, same stuff. All right, you can also group by as many variables as you want. So if we wanted to break it down further by county, we only have one observation per year and per county. So this is really just reflecting the only value that's there. However, we could do that if we wanted to. All right, so we may be interested in other summarizing functions. We've talked a lot about mean, sum, min, max, that kind of thing. But there's another function that's kind of handy, especially when we're doing these summarized tables. And that is n with parentheses, just a pretty small function. And it's just going to count the number of rows or observations. So it works very similarly to count, but we use it inside summarize. And so maybe if I was interested in seeing, how many rows do I have per each of these categories, I can confirm that I do only have one observation per year in county. Maybe I take county off of there. So now I can see that I have 64 rows per year. I took off that county breakdown that I mentioned. Again, N is going to give us the number of rows or observations. It does include missing values. Okay, so as I mentioned, count and N can give you very similar information. So we got all those 64s there. But if we took ER and we piped that into count by year, again, very similar information. All right. So a few things we want to just finally, touch on first before we get a little bit more practice. So we talked a little bit about N distinct. There are some base functions base R functions you might see that do something very similar. Again, not wrong to use either or, but you may encounter these in your work. And these are length combined with unique. And so these are going to require a vector. And so you may pull out the years from the data set using pull. So I've made here a vector called ER year using the pull function. And so I might be saying, all right, well, what are the unique years that I have? It's very similar to distinct. And here I've listed them out in a vector. If I combine that with length, it's going to give me the same value. So again, redundant information, but you may encounter those. So we take ER year, we're making a vector. Okay. So that's going to look like this. Lots of years repeated and repeated. And we could say, all right, well, what are the unique years? And then how many are there? There's 12 versus ER year and distinct will give us the same information. So I did just double check on this. I'm like, why did they feel the need to create this function and distinct? It is a little bit faster. So if you've got the world's most enormous data set, and distinct might work a little bit faster for you. But I think for most of our work, it's not going to make a huge difference. All right. So summary versus summarize. We mentioned this just briefly, but did want to remind us just because they are so similar. And that is summary is going to give us a statistics table on all of the columns of the data set that are numeric. And summarize is from dplyr, part of the tidyverse. And it's going to create a more customized summary tibble or data frame. Basically, it's going to only give you the statistics you ask for. And it works really nicely with group by. All right. So count is going to help you determine what unique values you have and how many rows of those you have for each. Distinct is going to tell you what are the distinct values. So, just if you have unique categorical information, what are those values? And indistinct with pull will tell you how many distinct values you have. But you can also probably just look at the output of distinct and see how many rows you have in that data. Group by is going to change all subsequent functions. So fun fact, it also works with functions like mutate if you're creating a column. So that's fun, a little bit more advanced to get into. And it works really well also with summarize to get statistics per group. Summarize can also work really nicely with N to give you the count of the number of rows, but just be aware that it does include missing values. So if you're trying to use that for information to, understand like a mean that was calculated, remember that the mean would get rid of the missing values. So important to think about that as well. All right. So before we jump into the lab, I did want to point out that there are some extra slides in this file for a little bit more advanced learning. If you're feeling like you're really crushing this, or you're like this has been a lot of a review. And there's also a really nice package here for creating more report quality summary tables and things like that. So, seeing them in the console, but also making them a little bit more print quality. All right. Any questions before we go back to our lab? Okay. Got a thumbs up. I think maybe we're feeling good. And let's head into those rooms. All right. I know I just asked, but any questions before we dive in? I'm going to skip some of the practice. Of course, feel free to play around with that. All right. So we're going to be playing again with this CES data set. And we want to know how many census tracts are present in each California county. We're going to use count on the column named California County. Use CES as your input data. I'll give us a moment to at least start that guy. All right. So we're going to use count, right? Because census tracts are, if we look at them, they're numbers, but really they're not like a continuous variable, right? Census tract is a discrete unit, just like a zip code, right? It's just a code for a category, right? And so we may be interested in kind of counting up how many are in each county. And remember, each line is a census tract. So each one is different. So one thing we could do is CES. And we could do count of California County. All right. So this data is a little bit different from the other one, from the ER data, right? So it's not like we have equal number of census tracts per county, right? We weren't doing like 12 years for each county, right? So Alpine County has just one census tract. I'm not super familiar with my California counties, but I imagine maybe this one is pretty rural, right? It only has one census area versus Alameda has a ton of census tracts. So probably a little bit more populated. In Fresno, that's a city. So that makes sense. Okay. Questions about this count? Hopefully pretty straightforward. Let me make sure that, okay, I'm not going to give anything away here. So one thing that may be of interest is to do an arrange step. So you could sort the county by the number of census tracts it has. All right. And if you want to see more about how arrange works, you can open up the help page here and see some examples. And you can use DESC to sort by descending order. So let me see if we can find an example of where they've done that. So they do descend around the column. So something like DES. And then, yeah, this makes sense. I feel like Los Angeles would have the most census tracts. All right. So let's break it down a little bit more. Can one use the function sort? Yeah, so let's talk about that a little bit. So arrange is part of the tidyverse, so it works a little bit more seamlessly with some of these functions. But let's bring up the help page for sort as well. So typically sort is going to work with a vector. And so you may have to just like prepare your data a little bit differently, like perhaps using pull to get it to sort how you want. But it does something very similar. So let me see if we can find an example down here. And I will say that, again, there's absolutely nothing wrong with using like base R and using things that are not part of the tidyverse. But I will say that when I see base R functions, it seems like they were intended to be used with vectors versus tidyverse functions work a little bit better with a two-dimensional object like a data set. So tend to work a little bit better, but again, there's nothing wrong with using them. Yeah, we could try. Why not? As I mentioned, they kind of work a little bit better with a vector, but let's see what happens when we pipe that into sort. Okay, so it's thinking the data is not really in the correct format. And so maybe something like if we were to, let's take a look at the data here. So approx location, this is a column that does not appear to be sorted, nor does California County, right? So they're not in alphabetical order. If I were to pull California County, that's going to give me a vector. Okay, that is alphabetical. The approx location, trying to find one that's not already sorted for us. Okay, so this one is not sorted, but let's see if we can get it to sort for us. Okay. So that worked better because pull is going to give us a vector. So now we have that data sorted, but it's now our problem is that it's a vector. So we might have to put the contents here into a new column. It's a good question. Some of these base R functions kind of seem like they would make a little bit more sense. All right. Any other questions about what's going on with these? I'm trying to see if there's any examples that might be helpful in here. Could have sworn they had some with data frames, but guess not. So let's break down the count a little bit more. So let's take CES. We'll do count. Remember, we did California County, and then we wanted to add another column. Let's try that. All right. So this time, instead of just tons of tracks, I have it further subdivided by zip code. And this is actually like really nice for me because, I feel like I can picture a zip code, but I can't really picture a census tract. Like does that mean like a block? Does that mean, how big does that mean? So to get an idea, it looks like in each zip code, it's like, between 2 and maybe 20 census tracts, depending maybe on how many people are in there. So that's helpful for me. I feel like that makes sense. All right. So this isn't the only way we can do this. So let's see if we can get fancy. So how many census tracts are in each county? Use group by, summarize, and N on the column named county or California county. Maybe we got that a little bit off. All right. So let's take the data to start, and we're gonna do a group by and do a summarize. I'll give us a moment to think about that a little. All right. So let's take this into group by. What do we want that grouping variable to be? We wanted to do it on the county, right? It's not actually named county, it's named California County. And so if I run that, it doesn't actually do anything to the data, but it shows me that it's got a grouping now. So that looks pretty good. But I actually want to do some summarizing. So we want to know how many of those tracts are in each county. So we can use the N function for that. All right. So again, this should give us the same information as this one up here. All right. How are we feeling about this one? Yeah, no, that's a good question. So if you did something like, yeah, just zip, something like that, if you take a look, it just named the column that. It could have been anything right here. It's just giving me a column name. Yeah. If we actually wanted to break it down by zip, we would need to put it up here in the group by. Maybe that makes more sense. Okay, other thoughts, questions, anything going on with this one? All right. Well, let's go ahead and try to modify the code from 2.3 to also group by zip code. We'll copy that in there. And I want another grouping. I want to add that column separated by a comma. And let's try that. All right. If we're feeling okay about this one, we could start to play around a little with it. So maybe, we're grouping by county and zip code and showing how many census tracts are in each one. But maybe we want to know what's the population for each of these zip codes. Do the sum of total pop. And I could think, okay, well, maybe I'm no longer interested in zip code. Maybe I cut that out again and run it again, and I can get the total population. And so, yeah, indeed, this one that has just one census tract has a very small population.